When I was growing up, I liked to watch a show called Sesame Street, and on that show, they had this character named Grover that taught me the difference between near and far. He'd run up close to the camera and say, near, and then he'd run really far away from the camera and say, far, and I quickly learned the difference. But sometimes I'm afraid that NSX may not have learned the difference between near and far, because with the power of a universal distributed logical router, we can create an appearance that all of our virtual machines are connected to logical switches that can route to each other regardless of their location. But the fact is, some of those virtual machines are in different data centers. One could be in New York City, the other could be in Sri Lanka. And although the VMs don't know the difference, someone connecting to and using those virtual machines would certainly know the difference if routing to the external world does not follow localized paths. Imagine if the virtual machine in Sri Lanka was trying to connect to the internet through a link that went all the way through New York City. That'd be craziness. So in this nugget, we're going to look at how we utilize the feature of local egress, which can be set up on a universal distributed logical router, and how to assign locale IDs on universal DLRs and hosts to accomplish the goal of localized routing. So to get a chance to show you how locale IDs work with NSX, we've opened up the VMware Hands-On Labs, specifically HOL 1925, fired up the browser, logged on to the vSphere web client as administrator of vSphere.local, and you'll notice on the left-hand side that in this environment we have two regions, region A01 and B01, each managed by a separate vCenter server. And of course, universal objects are all about crossing vCenter boundaries, but the additional element that we can add is specifically defining routing in such a way that it is different when assigned to certain locales, which will be defined by their locale ID. Let's head on up to the Home button and down to Networking and Security. Let's head over to Installation and Upgrade and just validate the state of our managers and transport zones. We can see we've got a primary and a secondary manager. If we go to NSX controller nodes, we can see we've replicated the controller to support universal objects. If we go to logical networking settings and head to transport zones, we can see that a universal transport zone has already been created, and we've already created 5 logical switches. Let's go to NSX edges. In NSX edges, we can see we've got a universal logical router that's been created. Sure enough, that's what's going to be associated with those 5 switches, as well as supporting uplinks. We also see that associated with the primary NSX manager, we have 2 edge devices, one for load balancing and one is a perimeter gateway. That's the one we're focusing on right now, the one called region A0 perimeter. And if we hop over to the secondary NSX manager from the drop-down menu at the top, we can see the universal distributed logical router is here as well, and this also has its own region B perimeter gateway. So in essence, we have something that looks like this. We've got region A and region B, and spanning across those, we have the universal logical switch, and spanning across those, we have the universal logical router. In each of these regions, we have a local edge device, the perimeter gateway for B, and over here, we've got the perimeter gateway for region A. And each of these is working their way up to local routers, which do in fact, behind the scenes, have the ability to route to each other. So what we need to do is utilize local egress, the capability here at this universal distributed logical router to control the routing traffic flow for VMs in region A or region B. And this works because routes are going to be advertised by the controller to the clusters based upon their locale ID. So region A routes will be advertised to region A ESXi hosts, and region B routes will be advertised to region B hosts. So for this to be possible, local egress must be enabled on the universal distributed logical router, and then we'll need to define locale IDs that will be used to bind together specific routes and specific clusters or hosts that actually deliver on the universal DLR promise. So back here in the vSphere web client, we're going to hop back over to primary for now. Going to open up the universal logical router, and if we take a look at the Manage Settings Configuration tab, we can see if local egress has been enabled, and it has been enabled. That's important because this cannot be changed after creation. So if this needs to be enabled and it's not, I actually need to build a whole separate universal DLR and reconfigure everything to use that instead of the one that is currently in use. But the good news is this one is enabled, so we can continue. So to start working with locales, we're going to go ahead and click the back button so that we're looking at networking and security. We're going to go to NSX Home. On the Summary tab, we're looking at our primary NSX manager, and what we're going to do is highlight this ID value that's already here and Control-C. We're going to copy that value. Now that we've grabbed this ID, we can start using it in the context of region A. So let's go down to Networking and Security. We'll head down to NSX Edges, make sure we're looking at primary, and we're going to open up the UDLR, head to the Routing tab, and we're going to take a look at our global configuration. And right up here at the top, there's a place for routing configuration. So we're going to edit that. We're going to paste in this locale ID that is the same as the NSX manager's ID. Then we'll click OK. And now we'll go ahead, we'll click Publish, and we have assigned a locale ID to this Universal Distributed Logical Router. Now that we've tied together the instance of the universal DLR with the locale ID, we're going to go ahead and assign a default gateway that makes sense for region A. So we'll click the Edit button next to Default Gateway. From the drop-down menu, we'll go ahead and choose the region A uplink and assign the IP address of 192.168.5.1 as the next hop router and click OK. We'll publish those changes. Now, let's get ready to blow your mind. We're going to go back to the Home menu, down to Networking and Security. We're going to head back to the NSX Home. And from the drop-down menu up at the top, we're going to switch to the secondary role. The ID is exactly the same, except that instead of ending in A, it ends in a letter B. But what's really important is simply the fact that it is unique. We'll go ahead and copy this ID as well. Now let's go back to NSX Edges, and from the drop-down menu at the top, we're going to go down to the role of secondary, and we're going to open up the Universal DLR 01 from the perspective of the secondary NSX manager. Let's make sure we're looking at the Manage Routing Global Configuration tab. And what I want you to notice is that this instance of the Universal DLR does not have a routing configuration or a default gateway. And that's because we're able to work with localized instances. So let's go ahead and edit this routing configuration. And we'll paste in the locale ID that ends in the letter B and click OK. Publish those changes. And then in this context, we'll assign a default gateway that makes sense for locale B. So we'll click Edit. From the drop-down menu, we'll choose the region B uplink and point to the default gateway of 192.168.5.9, and then click OK. We'll publish those changes. Now, in order for this to work, our ESXi hosts that participate in the Universal DLR must also be aware of the locale so that they can receive the correct, in this case, default gateway. So from the drop-down menu, we're going to go back down to Networking and Security. And we're going to focus this time on installation and upgrade, where we can see the ESXi hosts under host preparation. And we'll select the region A compute 1 host, head up to actions, and there's a place where we can assign a locale ID. And this is exactly what we want, the locale ID that matches the configuration of the manager. And this is exactly what we're going to see by default. We'll click Save. Let's validate the management cluster, head to Actions, change locale ID. Yep, that's set with a locale ID that ends in A. Perfect. We'll click Save. From the top, we'll use the drop-down menu and switch over to our secondary NSX manager. There's the region B cluster. We'll head to Actions and validate its locale ID. And there we go, the locale ID that's associated with B, because this cluster is associated with the region B vCenter server, which is associated with the region B NSX manager. So these are the defaults that we work with. To round this out, we just need to go ahead and make sure that we have the knowledge of the internal networks available internally and externally. So we're going to go to our NSX Edges and open up the Universal DLR here on the primary role holder. And first, we'll go ahead and add a dynamic routing configuration router ID. We'll go to the Edit button down at the bottom, and we'll create a custom ID, in this case, of 1.1.1.1, and click OK. Just needs to be a unique ID. We'll publish those changes. Then down under BGP, we'll go ahead and head to the Edit button and put a check mark in to enable BGP, and the local AS is 65,001. Click OK. Publish those changes. Then we're going to use the green plus at the bottom to add a couple of neighbors. 192.168.5.1 with a forwarding address of 192.168.5.2 with a protocol address of 192.168.5.3 and a remote AS of 65,001. In this case, we're not going to worry about filters. We'll just go ahead and click OK. Then we can publish those changes. Then we'll go down to route redistribution, and we need to make sure that we're injecting our connected routes into the BGP database. So we'll click the Edit button up at the top, put a check mark in BGP, click OK, go down to route redistribution table at the bottom, green plus, learner protocols BGP, and we're adding connected routes, and click OK. We'll publish those changes, just a basic BGP config. Now, some say the proof is in the pudding, but I think it's at the command line. So let's open up PuTTY and connect to our ESXi instances, and let's see what their routing tables really look like. So first, we'll connect to ESXi 01A, And here we're looking at a host that's participating in Region A that is associated with the Region A Universal DLR. Let's type in net-VDR minus instance, or you could just do a minus capital I minus L. This will list all the instances. And from here we can see that we have an enabled universal local egress router. So up at the top we see the name of the VDR, and we can see it has 5 lifts, those are the logical interfaces, and 8 routes. And if we want to see what those routes are, we can type in net-VDR minus route minus L. Nope, not minus L, minus the VDR name, duh. So let's highlight that, copy, and when we right click, it both copies and pastes to the line. Perfect. Press enter. And now minus L to list. There we go. Let's maximize that. Up arrow just to make it a little tighter. And we can see here in Region A, what's our default gateway? 5.1. We're seeing that right here on ESXi itself when it looks into its own mind and says, how am I supposed to get out of here? This is the answer it sees, along with the other routes that it's directly plugged into or that it has learned through the process of BGP. Now we're going to close that PuTTY connection, say OK, then we'll reopen PuTTY, and this time we'll connect to ESXi 1B, which is a device managed by our secondary vCenter server and NSX manager. Once again, we'll type in net-VDR minus capital I minus lowercase l to say list the instances. We can see the same exact VDR name, but although it has 5 lifts, it only has 6 routes, and that's because it's in a different network, uplinking to a different edge device. Let's see what those routes are. We'll type in net-VDR minus route space, highlight, and right-click to copy and paste that edge VDR name, and minus L to list those routes. Once again, maximize up arrow. And in this case, we see that we have a little different routing information because we're in a different network. But the important thing to notice is that here in Region B, we have access to our default gateway pointing up to 192.168.5.9 instead of 5.1. One universal gateway, but we have localized the routing so that it is efficient depending on which location the virtual machines are in if they need to emerge out of the DLR and into the rest of the network. My friend, by going through this nugget together, you've learned how to manage local egress by assigning locale IDs. These unique IDs that'll bind certain routes to certain clusters so that things like a default gateway or other static routes can point in the direction that is needed in that localized environment. I hope this has been informative for you, and I'd like to thank you for viewing.